In the next 10 days, you will see different concepts, theoretical mostly, coming again and again, and it will come until even the 8th or 9th day. So what I will do now in this session, sort of set the tune in a way. We'll discuss about single dimensional poverty, but the concepts that we will discuss here, they mostly be extended in the multidimensional context. So tomorrow morning we will be discussing some of the multidimensional measurement methodologies in the first session, and you will see there are some obvious links between these. Also, over time we will talk about robustness checks, we will talk about inequality, and all those issues actually you will find very much linked to what we are going to do in the next 1 hour and 45 minutes. So I call this session as a review of unidimensional poverty measurement. I understand that one session, just a 1 hour 45 minutes long session, probably is not enough to summarize all the concepts, but we will mostly discuss the basic concepts and touch upon the properties or the axiomatic issues, but we will not go that detailed, but we'll touch upon all this. Text, of course, we would suggest you to look at the book that we have written. We have a short section. We don't have an entire chapter on unidimensional measures, but we have a very short section where you can see sort of the basic review and the notational points and so on. With James Foster, we also wrote a book that was published from the World Bank, which is actually available free. You don't even have to pay anything to read that book. That is available free from the World Bank website. Some of these basic measures are covered over there as well. This book is called the Bible in our field. Everybody who has studied inequality, poverty has, of course, read this book. Okay, and then James Foster also had a review of poverty indices, and we draw some concepts from there as well. So these are sort of basic readings. Other papers, more details, if you're interested, they are listed in your reading list. So you are welcome to go through the papers as required. So here are the preliminaries. When we are measuring poverty, as Martin, the main focus in earlier lecture was countries. But the questions came up: could we do ethnic group? Could we do geographic regions, and so on? So what we will do, we will just refer this particular reference population as a society. So suppose we have a society, and we are interested in assessing the poverty of that particular society. So when I refer a society, it could mean a country, it could mean a particular geographic region, it could mean a particular ethnic group, and so on. Unit of measurement we refer as person. Okay? Identification can take place at the household level as well. If you are interested in child poverty, then each unit of observation, unit of measurement would be children. You leave out rest. When you are doing Women Empowerment Index, probably your unit of observation or unit of measurement would be women, okay, not men. We would refer them as person, just a general term. And we assume that there are n persons in the society. N can vary because we'll be comparing societies, countries, regions of different population sizes. And variables or dimensions for assessing poverty, we refer them as space. It could be income sources, it could be consumption of different commodities, whatever you want to do. And we assume, suppose you have D such variables, and this D we assume fixed in general. I mean, in reality, when you are assessing poverty across countries, you may say that the commodity baskets may vary, but then the issue is that when you change these commodity baskets too much, your poverty measures are becoming incomparable over time or across cross sections. So it's a mild assumption. So we just assume that there are suppose D such variables, and they are sort of fixed. And when we will be moving in the multidimensional context, you will see, as Sabina will be talking, and we will be talking from tomorrow, we'll be using similar notations. And you will see that when we change the set of indicators or set of dimensions, again comparisons across space and across time, they becomes difficult. So we just make this mild assumptions that suppose we have a fixed set of d variables. Achievements. So we refer the performance of a person in a dimension as achievement and denote it by this term x, substitute I and j, where I stands for the person, which can range from 1 to n, and j stands for the dimension, which ranges from 1 to d. So xij is the achievement of person I in dimension j. We'll be using some matrix notation, and an achievement matrix would summarize all the d achievements of all the n persons. And this is a particular matrix will come back again and again. Okay? Here what we do, this capital X denotes the matrix. Here you have the columns which represents dimensions, and then you have the rows which represents persons. So this particular matrix is summarizing all in or the achievements of all n persons in d dimensions. So this one, x11, is the achievement of person 1 in dimension 1. Similarly, x2d is the achievement of person 2 in dimension d, and so on. Achievement vector of a particular person is then this one. So if you ask what is the achievement vector of person n, then you have this d-dimensional vector denoting the achievement vector of this particular person. Now these achievements in monetary approach world, in monetary world, what would these d achievements would consist of? It may consist of incomes for d different sources, or it could be the d different commodities consumed. This is what we in general mean achievements when we are talking about monetary poverty. Now if you are just analyzing something else, you could think about in multidimensional world, for example, these achievements could be income, education, health, and so on. So the overall achievement of each person, you have this income, or you have these different commodity bundles. How we aggregate them? Let's suppose we denote them by capital small x of I, which is obtained by meaningfully combining d dimensions. What do you mean by meaningfully combine? As Martin was saying, and probably James will argue again tomorrow, as long as you believe you have, for example, in consumption poverty world, as long as you have the price bundle and you assume they are the right kind of commodity price bundles, yes, you can always aggregate the commodities up. If you think different source of incomes can be aggregated to obtain a single income figure, please go ahead and do that. As long as you can meaningfully combine and you have reason to combine, yes, you can definitely combine that. And then you can get a resource variable or a welfare indicator. When the space is set of income sources, income from labor, income from capital, income from wage earning, and so on, if you have different categories of income, you can sum them up to get the overall income simply. And when it is a space of set of commodities consumed, then you can again use the price vector to get the welfare aggregate as the total consumption expenditure. But of course, for that, your price has to exist. If it doesn't exist, we cannot meaningfully aggregate. So here's an example.
Excuse me.
Yeah.
So when we do this aggregation, particularly in the commodities case, when we're also assuming inherently the compensability in the sense.
Of course, yes. You have to make all those assumptions. We have to come. So I'm not going that detail here because I'll mostly be discussing the measurement issues. But of course, they are there. You have to make different assumptions, rationality, and so on. All these things. I'm not going in that details. Okay, but the main idea is that once you have that and you can meaningfully aggregate, you just get the aggregation and get this particular welfare indicator. So here is a simple example. So what I will do in this lecture, I know that you are at different levels. Okay, some of you may find it very basic. Some of you find it very advanced. But as Savina mentioned at the beginning of the lecture, the idea is that after first 2 days, we would like you all to bring on the same boat at the same level. So that's the idea. So I will go with the slower side. but please do not see the disadvantage. Okay, we will be benefited from each other throughout these next 2 weeks, definitely. So, so suppose we have this example that there are 4 persons in a society, and you have these 4 different incomes. Then the vector x would consist of these just 4 elements, 9, 4, 15, and 8. This is the vector representing the income of the society. If you order, and we will see in the next slides why we are interested in ordering the incomes. If you order them, you can order them in this way. So 9, 4, 15, 8 can be written as 4, 8, 9, 15. Why do we benefit from ordering them? The idea is that once we order, we can also represent this particular vector as a cumulative distribution function, a CDF, which makes our life easier. We have a visual depiction, and this cumulative distribution function, I will come back towards the end when I'm talking about stochastic dominance, and also we will come back to this next week when we are talking about the robustness issues. So suppose we have this particular vector, and we can order them to 4, 8, 9, and 15. Then if we ask how many people or what fraction of this population has income less than 4? 0, right? So this is what you get here. What fraction of the population has, say, income less than 7? 1/4. This is what you get, and so on. So if you just use these things, you can just then create this particular cumulative distribution function. This is how it looks like. Now when you have a sort of more continuous distribution, how it looks like, this is how it looks like, right? If you ask here, what does the CDF tell you? It tells us the share of the population having income less than this particular income level. So fx4 is the share of the population with income less than equal to 4. And you will see how this idea can be used or can be linked to headcount ratio, right? When you talk about headcount ratio, and you have definitely heard the name, Martin just presented, headcount ratio is the same thing. What fraction of the population has income less than $1.25 a day, right? So you plot this distribution, and you just look at them. Great. Now, here, after we have this distribution, we observe this distribution, a policymaker is generally interested in the following 3 aspects of the distribution: size, or the welfare, okay, spread or inequality, and then base, which is poverty. What is this poverty? Which is sort of the welfare of the population below a certain level of income. If you are trying to improve the entire distribution, it may not ensure that the situation of those who are at the bottom of the distribution has improved. So you try to focus on that particular group. How you define your poverty line? Well, you had an entire lecture just beforehand. It could be highly debatable. But anyway, if you have that particular poverty line, you can identify that base of the population and keep your focus on that particular base. And of course, in the summer school, as you have seen from the title of the summer school as well, we are focusing on this base of the distribution, this third aspect. Okay. So for poverty measurement, the unidimensional poverty measurement involves 2 major steps after you have chosen your space, by the way. You have to choose your space, whether it is income, whether it is consumption, whatever you choose. Then it involves 2 major stages following Sen's seminal article in Econometrica, is identification and aggregation. Identification, you mainly ask who is poor. So this step actually dichotomizes the population into a group of poor and to a group of non-poor. And in poverty measurement, your focus remains, there is a property called focus, and your focus remains particularly on the set of those who you have identified as poor. Main tool here is the poverty line, how to select the poverty line. So if here in this lecture mostly we will focus on and discuss all the properties and so on in terms of an absolute poverty line. And anyway, it's a cross-sectional thing where and one particular country. So however you choose the poverty line, it should be okay. Okay. So we will mainly be focused on the absolute line here.
But
So
if we choose relative poverty line, then the focus would not be valid, right? The focus action would fail.
why?
Because what would happen to the rich people's income?
Exactly.
That would change the median and that way.
Yeah. Okay. So here, what we'll do, we will focus. We will concentrate mainly on absolute aspect of poverty line. So person I is poor if xi is less than z, and is non-poor if xi greater than equal to z. In the literature, there at one point of time there were debates on whether those who are equal to the poverty line, whether they should be identified as poor or not. There is a paper by Donaldson and Wimmer in 1986. And if you look at this paper, that paper tries to actually show, depending on these two different definitions, it is possible that different measures can give you different results. Okay. In general, it is the norm to focus on this particular definition. Identify those who are strictly below the poverty line rather than and exclude those who are there. It makes just life easier.
I mean, can you hear us? I mean, instead of assuming, why absolute, why relative? From practical.
It's not absolute relative. Even if you have absolute, we are saying that as long as you are not achieving that threshold, you are poor. As soon as you achieve that threshold, you become non-poor. Right?
No, I get that. From your presentation, we are considering that one is absolute.
Yes, it's
That's
absolute.
very relative.
It's absolute.
Yeah.
It's absolute. It's not relative.
Yeah, why
Because as you
that's
said.
I mean for the
So, yeah, look, if you go to completely relative, so the basic things we will be discussing about absolute, because it just facilitates your understanding about different properties, okay? Relative you could do, it is not going to be extremely difficult, but the thing is that as pointed out that your main property, the focus property, that you focus on this particular people, it may change. So you have to adjust the focus property in different way, but the adjustment can be done. Okay, but for simplicity, we will just focus here on the absolute poverty line aspects. Significance of the poverty line, I don't think I have to go much on this slide. You already had an entire slide, but still, it enables the policymaker to identify a group of people who are subject to different social assistance. It's called targeting. And then poverty line can also be set as a benchmark where you want this population who are deprived, at what level you want them to achieve. So you can use a poverty line in these two different ways, one called targeting and the other when you do the benchmark thing. When you are doing targeting, mostly you stop at the identification stage, right? You don't need to aggregate or whatever. You just identify the set of people who are you think should be targeted, and you just focus on this particular population. When you are doing measurement, then after you identify those who are poor, you use their achievements, right? And then build up a particular aggregate measure. Okay, so this is the censoring part. As I said, that one of the main properties or one of the main aspects of poverty measurement is that you want to focus on those who you identify as poor or deprived. So what you do, you just assume those who are on or above the poverty line, they have already achieved the threshold. You do not drop them from your analysis. So that means you don't truncate the distribution. What you just do, you censor them. You just assume they have achieved already the required income. So I just assume them as equal. They don't need any assistance. I treat them as something that they have achieved. They're equal. So what you do here, you retain those incomes which are less than below the poverty line, and you censor, you give everybody a same value of Z if they are on or above the poverty line. In example, how you do, if you have a poverty line of Z equal to 10, and you have this distribution of X, then X star becomes 9, 4, 8, you retain these values, but 15, which is above the poverty line, you substitute it by 10. This is called the censoring part. Now, if you have this distribution, entire distribution, and you know your poverty line, how are you going to censor this distribution? Graphically, you have this poverty line, Z. What you do, those who are above, equal or above the poverty line, you just change them. So you just substitute their incomes by the poverty line. So you're censoring, but you return them, you don't drop them. And we will discuss why it is not a good idea to ignore those who are above the poverty line. You could say, you know what, these are the people, they are above poverty line, so ignore them, drop them from the distribution, but that brings some irregularities in your measurement. It is not ideal to do that. You keep them, you censor them, and then you do the poverty measurement. And we'll come back to that point. Aggregation, the main question you ask, how poor is this society? So this step constructs an index of poverty summarizing the information in the censored achievement vector. So for each distribution and poverty line, P of xz or P of x star, because x star is nothing but the censoring of this distribution subject to this poverty line, measures the level of poverty. So whenever we are writing P of xz, that means poverty in distribution X subject to this poverty line Z. And we will come back to these notations again and again. Now, this is quite crucial. Suppose you are trying to measure poverty. And even before finding out a particular measure, you may want to know, if we have certain changes in my distribution, how my poverty measure should behave. So even before constructing a poverty measure, you need to understand, or you need to agree on some normative aspects that I want my poverty to change in this particular way. Suppose there is no poor persons in a society. How do you like, what value do you want your poverty measure to give? Not 1 million, it may not make sense. Right? So these are some basic things. So what we will do, we will just consider some examples. So instead of going through all the theoretical properties, we will go through some examples. We will debate on the examples, and we'll see if we all agree on how the poverty measure should behave, and then we'll see what the literature says about these different properties. Example 1. Suppose you have this particular two distributions. You have two societies, X, and you have another society, Y. And what you do, somehow you rank your data set by, alphabetical order of the names. Okay? And in society X, you get 5, 4, 4, 5, $5, $4, $4, $5. In society B, you observe the incomes to be $4, $4, $5, $5. Which distribution should have higher poverty?
What's the question?
The question is, you have these two distributions, so society X and Y, and you have just ordered the incomes by the alphabetical order of the names. Which society, X or Y, has more poverty? Who disagrees that they should be same? Please raise your hand. One disagreement is there. Why do you think they should not be same, you said?
No, they overheard.
Overheard. So these should be same.
They should be same.
Okay. Everybody agrees that universally?
Maybe.
But here, in general, if I observe from outside, these two different societies have these same income distributions, okay, it doesn't matter who has got particularly what, I treat these two societies as same. And this particular property is called symmetry or anonymity, that you treat each agent as anonymous. You have two different distributions, you don't know who is who, you don't know, do you know anyone in Afghanistan? Anyway, I'm just kidding. So you do not know these two particular societies, you just know their income distribution, you treat everybody as anonymously. And if they give the same distribution, you say they have same level of poverty. That's the idea. Example 2. You have one society here. How many poor are here? 2. And here you have 1, 2, 3, 4, 5, 6, 7, 8. 8-person society. You have 3 of them as poor. Which society has more poverty? And why? One by one.
Why?
First, why has more poverty? Why?
There are 3 more people. There's 1 more person.
Well, but then there is 5 more people to support him.
I'm just supporting poverty
But we're
program there.
we're focusing on the poor, right? So we're counting the poor.
You are counting the absolute number of the poor.
Yes.
So it does not matter whether you have a big society with many rich people, lower number of poor, okay, fractionally. Then you have another society, very small, suppose in Africa, you have 90% of the population poor. You still would give that richer country which has absolute more number of poor as more level of poverty. And would everybody anonymously agree that the second society should have more poverty?
Yes.
Disagreement. Who should we support?
I mean, in terms of share of population, second has less, but in terms of absolute number, second has more.
Right. So you have an ambiguity, but somehow you need to make, so depending on what judgment you take, you will have different level of poverty. The literature takes sort of a neutral position. And this is a property that says replication invariance, which argues that if you replicate, if you clone everybody in a society with the same level of income, and you create sort of a duplication of a society, then poverty should be same in these two societies. That means if you have this particular distribution 9, 4, 15 and 8, and you just create, suppose you have another society where each of these incomes has been replicated twice, says that this such replication should not alter the level of poverty. You see, I mean, you could go either direction. You could say this society has more, this society has less, but this is an independent position. And if you have this particular position, it is actually possible to compare these two societies. Okay, you clone this society and clone this society so that they have the same number of population, right? And then you can check which society has more poverty and which society has less. It will turn out this society, so this society has more poverty in that sense if you take this particular stance, which may sound reasonable. But I completely argue that one may say, you know what, one society where there is more poor, it doesn't matter where they live, could have more poverty. So if you argue on that way, in that particular direction, you have to adapt your measure. So you will not be using head count ratio, rather you will be using head count as your measure. So you will count, so your poverty measure would be the absolute number of poor in each country and rank the society that way rather than ranking them by their head count ratios. So your choice of measure will depend on how you or what kind of outcome you want to achieve. Not just selecting a measure and then check it has gone up or down. Okay, so it's a normative choice involved. Good. Example 3. So you have again two distributions. You have X and you have Y. And here you are measuring everything in dollar. Here you are measuring everything in pounds. You have changed and updated the poverty line, updated every income. So it's just a mere change of exchange rate. Which society should have more poverty? Which society should have less? Do you anonymously agree? Okay. This property is called scale invariance. So that means if you merely change the scale of your particular indicator, and this is mainly the justification of using any particular measure that should be invariant of this scale. So the main idea is that if you change each income in X and the poverty line in the same proportion, then the poverty rate should not change. Now one may come actually, I mean, you can see the relevance of this property, right? This property actually comes for this convenience issue. Okay? But then there are people who has come up with this particular property called translation invariance. They say that if you add a particular amount to everybody's income and add the same amount to the poverty line, the poverty line should not change. And it actually can be shown that depending on again what your requirement, your poverty measure can be different. But here is one argument which is convincing argument that if you just change the unit of measurement, then your poverty measure should not change.
Mr. Corey,
Yes,
the
questions, yeah.
translation invariance is multiplicative with respect
Yeah.
to the
Yeah.
life.
But that is the main motivation. You see, if you look at this example, you're just multiplying, you're just changing the exchange rate. Exchange rate is all about multiplying. If you do that, it doesn't change. Now you could also sort of require this translation invariance, which requires that if you add a similar amount, same amount to everybody's income, and also you add the same amount to the poverty line, poverty should not change. So one is proportion, one is amount. And there's an econometric paper which shows that the only measure that satisfies both these scale invariance and translation invariance is the headcount ratio. So if you require both to these two properties to satisfy, you cannot use anything apart from headcount ratio. But we will come and show the problem of headcount ratios, different problems that it can bring. Example 4. You have this distribution where you have 5, 4, 4. How many poor are there in this society? 3. So you have 5, 4, 4, and then 15 is the person who is non-poor. What is the difference between these two distributions?
They're the same.
Are they?
If you're going to censor.
If you are going to censor, so you have to agree on censoring. Okay? So that means if you censor this distribution, so what you are saying literally here, that if there is a change in a non-poor person's income, there should not be any change in a poverty measure. Do you all agree? And this property is called focus, which means our focus should remain on those who are identified as poor. So if you obtain y from x by an increment to a non-poor person's income and the poverty line remains unchanged, then you have same level of poverty. Now, if you go to the multidimensional context, there are actually two different kinds of properties. One property is very similar to what we get here. That means if you have a change in any non-poor person's achievement, you should not bother until and unless that person becomes non-poor. So if you have an improvement in their situation, overall multidimensional poverty should not change. Then there is another related poverty, and Sabina will talk about those things tomorrow, and we will be talking about in the morning as well. Because in multidimensional case, when you move there, you have different dimensions, right? You have income, you have education, you have health. Now it is possible that a poor person, somehow identified, is not deprived in a particular indicator. Suppose you have 3 dimensions, income, education, and health. You have a particular person who is severely deprived in health and education, but probably not in income. The question is, if we change, if there is an improvement in that non-deprived indicator, which is income, should the overall poverty change? And the deprivation focus says that even if a poor person is non-deprived, and if there is a change in that non-deprived indicator, then poverty should not change. Not all poverty measures, as we will show, typically if we use principal component analysis and many other methods, it actually can be shown that there are many of these methods that actually do not respect that particular property. So, even if for a poor person, they have improvement in their non-deprived dimensions, multidimensional poor, poverty can change. So you can drive somebody out just by improving their non-deprived dimensions. They can still remain deprived. Okay? Yeah.
You ruled out by this property. You ruled out all the relative property lines.
As I told you at the beginning, I'm just for these concepts, I'm focusing on absolute poverty. So the poverty lines are absolute here. Okay, we are not going. And when you are in ordinal world, for example, and Sabina will talk about ordinality and all these aspects, sometimes we still do not know how we can do the relative issue over there. Okay? we haven't done that far yet. So for this moment, I'll focus everything on the absolute poverty line measure for the understanding. But of course, they can be updated for relative measures. But for this focus, yes, it is required we focus on the absolute line, not relative. Any other questions? Okay. Let's move to example 5. What is the main difference between these two distributions?
It's the depth of poverty that's different.
Right. So for one person has higher income, one of the poor persons has higher income. Which distribution should have higher poverty?
X.
X.
No, in terms of headcount ratio is the same.
Sorry?
In terms of headcount ratio is the same.
But I am not using a particular measure. I'm asking you if you are a policymaker.
Income poverty is different.
No, wait a second. Well, I am asking you, would you rank these two distributions differently? What measure you will be using will depend on what you want to happen. So is the question even before constructing the measure? Do we even want to see these two distributions differently?
Yeah.
If yes, how to rank them? Which one is better? Which has more poverty?
X
X has more poverty.
more different.
So the idea is that if you obtain a distribution from this distribution by simple increment in the income of a poor person, and everybody else's income remains same, then your poverty should go down. This is called monotonicity. So monotonicity requires that if y is obtained from x, I am just presenting in a different way, a decrement in the income of poverty among the poor and z remains unchanged, then poverty should go up. Okay? And weak monotonicity, what it requires is that you allow for this equality here. Now, what is the difference between this and this? This requires, monotonicity requires that poverty in this situation should strictly change. That will rule out headcount ratio. This property will, however, not rule out headcount ratio because you are allowing the possibility that your poverty may remain unchanged. But note, why is this weak version significant? It is preventing you or preventing the poverty measure to move in the wrong direction. So that's why the weak versions are also important. You could say weak versions, leave things neutral. But well, that's a strength as well. At least you know that if there is an increment in a poor person's income, poverty will not go down. That is what it prevents. Clear monotonicity? Okay. Next, example 6. This is a bit tricky. We are going too far following Sen's own article, Sen's original article of 1976. Look at these two distributions. What do you find common in these two distributions and what is the main difference? How many of them are poor in these two distributions? All of them, right? What are their average income? Are they different? They're same average. So what is the main difference? Inequality among the poor. So, in this particular society, you have a group of people who are extremely deprived. And you have a group of people who are much closer to the poverty line. Here, well, they're they're bad, definitely, worse than them, but they're not so bad. So how would you rank? Sen ranked in its own way, but how would you rank these two distributions? Would you consider them as equal? Or you prefer, or you say there is less distribution in one, less poverty in one distribution than the other? X has more poverty. Equal. No, the wrong way. But anyway, then you could always say that okay, it didn't change. As long as they have average income, it's poor anyway. I don't care about inequality between them. Okay, one can allow them to remain the same. But it's hard to argue that this distribution has more poverty than this distribution. So you could have a transfer principle. You could say if y is obtained from x by a progressive transfer among the poor and z remains unchanged, then you have this particular reduction. Similarly, you could have a weak transfer principle. which allows, if you do not care about inequality, and if you evaluate them same, you would allow this particular weak inequality here. Okay? Now, what is progressive transfer? Because in the last one, I mentioned that progressive transfer among the poor. When I say progressive transfer, which means you have, suppose these two incomes, 1 and you have 9. What you are doing, you are taking away, say, $3 from this person so that this person's income becomes 6, and you transfer it to this person so that he gets 4. This is exactly what we had in these last two distributions, right? One distribution had 1199, the other distribution is 4466. So the distribution 1199, you use that to obtain 4466. So you just reduce inequality. So this is one way of reducing inequality. Is there any limit on the amount of transfer? It says that yes, it does. Post-transfer income cannot fall below the lower pre-transfer income. So you cannot transfer in such a way that this person's income falls below 1. So that is the restriction on transfer. So that the post-transfer incomes should be at most equal to this 1 and 9. It cannot cross this particular limit. Anyway, now one may ask, well, you are talking about here single dimension, you are talking about incomes. We can see how you can transfer some dollars from the richer person to the poor person. What about education? What about health? If you are doing education inequality or health inequality? Well, the way you can argue, first is that you can do transfers implicitly. If you find a particular income category, higher income category having better health, you can try to transfer income through taxes and so on to give those people who are much poorer, suffering from bad health, through public services. Or you could argue, if we see two different societies, in practice they look like as if one has been obtained from the other by a transfer. You can have these two different kind of societies which look like this. Then you can rank one society as high, one society as lower. So this idea of transfer may not work for some dimensions, but if you see these two dimensions in such a way as if one could have obtained and you have them in reality, you can rank them. This is the power you get from this particular property. Okay. Example, I'm coming towards the end. I have one or two more examples. So you have this particular society. What you have done, this is what you often do, geographical analysis or group analysis across ethnic groups. So you have this overall vector of 9, 4 and 15, 8. You have x1, you have one group which is 9, 4. You have another group called 15, 8. You divide them. Now suppose y is obtained from x such that y1 is equal to 6, 4. You can see the difference between these two, right? What this poor person's income has gone down. So his income has remained same, his income has gone down, and suppose y2 in this subgroup there has been no change. What would you expect the overall poverty to happen, the overall poverty comparison between x and y? I repeat again, you have this overall vector x of 9, 4, 15, 8, you divide them in two groups, red group and blue group, right? In the red group, poverty has fallen over time. In the blue group, poverty has remained unchanged. What will happen? So overall poverty you would expect to go down, right? So this particular property is called subgroup consistency. It was a work following James Foster. So it says if y is obtained from x such that poverty has increased, say in one subgroup, but is unchanged in another, and total population size in each subgroup and the poverty line remain unchanged, then poverty should go up. Just to give you an example, similar idea you can use in inequality measurement, right? So you are saying that suppose I have divided these two countries, or one country in these two different subgroups, mutually exclusive and collectively exhaustive subgroups. And now my inequality has gone up here, and inequality has remained same here. You may, for some measures, some of the well-known measures, you observe that although inequality went up in this group and remains same here, overall inequality has gone down. Gini coefficient is an example. Okay? You may see that Gini coefficient for one subgroup has gone up, the other one remains same, overall Gini has gone down. Because Gini is quite sensitive to income changes in the rank changes in the middle of the distribution. So, as a result, any poverty measure that is dependent on Gini inherits that particular problem within it. So you have a reduction in poverty in one region, poverty remains unchanged in another region. It is possible that overall poverty has moved in the wrong direction that you do not want to see. So subgroup consistency property, if you require that, fixes that problem. Subgroup consistency actually will suggest you not to use the measure proposed by Sen in his 1976 article. You could have this particular problem. Now, practical reason why you need subgroup consistency property: evaluation of poverty reduction programs. You have different geographical regions or different ethnic group. You have worked very hard for a particular ethnic group. Poverty has gone down for them. Probably didn't change for the rest. And your lower poverty goes up. It's not very consistent. It can also be seen as an extension of the monotonicity property. But can anyone say what is the subtle difference between monotonicity and subgroup consistency? What was monotonicity? Monotonicity was if you had, say, an improvement in a poor person's income, overall poverty should go down and vice versa. And subgroup consistency is saying if you have increase in poverty for one group, the other remaining the same, the overall poverty should fall. What is the subtle difference between these two?
Is it the monotonicity? I mean, you can say subgroup consistency is same as monotonicity if you assume that group strength is just one.
Right. In the subgroup consistent property, what we are saying that the poverty in one group has gone up or gone down. Now, poverty can go up by simultaneously improvement and deterioration in situation of the poor. So here we are just thinking of the entire group. So when you have two persons in a society and yet you divide them in two groups, monotonicity will be equivalent to subgroup consistency. Okay, a related one, and this is something that is often used, and you will see when Sabina and James tomorrow, when they are presenting their measure, this property will come up. And this is called additive decomposability. This is also very useful for policy evaluation, where you say that the overall poverty, if you know the poverty levels of the subgroups, okay, and you know their population shares, then the overall poverty should be recovered from the subgroup poverty by taking their weighted average. Population share. You use the population share as weighted. This is called simply additive decomposability. Here, one may compute the contribution of each group to the overall poverty as this. You have the population share and the ratio of the poverty level of this particular group to the overall poverty. It is the contribution of this particular group to the overall poverty. And you may be interested. Many of you may be interested in knowing that when you are doing policy evaluations. Okay, and then finally, I'm not going to give you examples. There are two core properties, we call them technical properties. One is normalization. A poverty measure should be bounded between 0 and 1. A well-known poverty measure proposed by Watts, many of you may have heard that measure, Watts measure, is not bounded by 1. It's bounded below by 0. So the idea is that when you do not have any poor person in the society, you should have a value of 0, not a value of minus 1 million or plus 1 million, which makes sense. And it says that when you have the maximum level of poverty, the upper bound should be 1. But there are some measures that may not follow that property, but that doesn't imply they are bad measures all the time. But this is a mainly convenient property. And then continuity, it says that a poverty measure should be continuous on the achievements. This just prevents sudden jumps. Headcount ratio is not consistent. is not continuous. Why? You keep on changing. Suppose between two incomes there is a gap. If you change your poverty line, there is no change in headcount ratio. Suddenly, as soon as you reach that particular, the next income level, headcount ratio jumps up. If you use poverty gap or square poverty gap that we will discuss now, they satisfy this continuity property. They don't have these sudden jumps. But it is not a necessary property. You can design your measures which are discontinuous but miss out well. Okay, so how do we classify the properties? This is following James Foster's 2006 paper. We call some properties as invariance properties. It ensures that poverty measures should not change under certain transformation of achievement matrix. Can anyone tell me any of the properties we introduced that would fall in this particular category? That you have changed, sorry?
Symmetry.
Symmetry, yes. Thank you. Replication invariance, wonderful. Scale invariance. You could have translation invariance. So all these invariance properties you have changed in your data, different transformations, but poverty level doesn't change. Dominance properties ensure that poverty measures should increase or decrease due to certain transformation in the achievement matrix. Which properties? Monotonicity transfer. Wonderful. Thank you for reminding. The first summer school where everybody is remembering the properties. So nice. Good experiment worked. Thank you. Subgroup properties. Subgroup consistency and decomposability. And then you have the rest of the technical properties, which your continuity and normalization. Wonderful. Thank you very much. Okay, so now what we will do, we will move to poverty measures, and we will discuss some of the poverty measures that we will be using throughout this lecture. Sabina and James will be presenting that the Alcar-Foster class, which are extensions of this particular group of measures. Okay, and there are some advanced measures as well. We are not discussing here. If you're interested, they are discussed in that World Bank book in details. Okay, so first, the headcount ratio. It is the most commonly and widely used measure of poverty, and it reports the proportion of population that is poor ranges between 0 and 1. If Q is the number of poor in vector X with population size n, then the headcount ratio is Q divided by n. Example, if you have poverty line of Z equal to 10, if you have the distribution of 9, 4, 15 and 8, then H is simply equal to, 3 over 4. It's clear, right? It's not a difficult measure at all. Now the question, what properties does this measure satisfy? Because you need to know, when you are designing a measure, you need to know how a measure will behave when there is some changes. H satisfies symmetry, replication invariance, scale invariance, focus, normalizations and subgroup consistency. Not that bad in that sense. However, if you want it to satisfy these two, which are quite crucial, right? If you have a transfer, you wanted to improve the situation of the poorest of the poor, you did a great job, but none of those poor crossed the poverty line, their situation improved, they can just cross the poverty line, I do not give you any benefit at all. Tough
But
life.
that can happen, I mean, practically.
Yes. And do you want, you are a country government, do you want to be acknowledged for that, or if I say there is no change, will you be happy about it?
I mean, technically speaking, you can say, but your model shouldn't have to, you don't have to restrict your model, I mean, to give you such kind of results. Instead,
Exactly. So when you are devising headcount ratio, and if somebody comes to you with a great measure, you should be able to say, but look, it should have this kind of properties. That is the main idea of understanding properties. So that you can tell people what you are missing, not just what you are getting. And if you understand these properties, it will help you. Who knows, tomorrow you design a property measure which doesn't exist. You do it for a purpose, right? Then you should be able to say what it can do and what it can miss. So that when that missing part comes, you do not remain silent by saying, you know what, I don't know what is happening. That's the idea. Just like riding a plane, right? You're a pilot. You should not be able to say, you know what, I can push this one, I don't know what is going to happen. Deadly. Anyway, policy implication, it encourages policymaker with limited budget to assist the marginally poor, those who are living very close to the poverty line, and deliberately ignore those who are the poorest of the poor. Because if you have just $1 to pay, and it's an indivisible dollar, right? You cannot divide the dollar. You have this $1, who you should give? To those who are living very close to the poverty line, or those who are living really below the poverty line? You probably will end up giving that person who is living very close. If you give that $1, that person will cross the poverty line, right? So you can see how it can also drive the incentive of a particular policymaker. Let's look at the next particular measure, which is poverty gap ratio. Have you heard about this particular measure? Right? So what it does, this measure repairs some of the problems of the headcount ratio. It reports the average normalized income shortfall from the poverty line using the censored distribution. How do you do that? You take this average normalized shortfall of each person, which is denoted by GI star, is just Z minus XI star divided by Z. So those who are identified as non-poor, how much value do they get? 0, right? Right? So those who has already crossed the poverty line or on the poverty line, they get a value of 0. Then what this measure does, it just takes the average of all these elements. So for this particular person who is the poorest, suppose the poverty line is 10 and somebody has an income of 0. What is the normalized gap? A poverty line of 10 and his income is 0. What would be the normalized gap of that person? 10 divided by 10 is equal to 1. Okay, highest possible gap. So you will take that person and those also who has 0 and so on. All these n, we have n persons, right? You will have all these n normalized gaps and just take the average. And this particular measure can be presented as in this particular form. H is the headcount ratio and I is the income gap only among the poor. And this is how it looks like. I is the average income shortfall only those who are poor. So it is, the poverty gap is H times A, and you will see a very familiar form of another measure which will be called adjusted headcount ratio, which is also, you will see H times A, that A is the average deprivation share. Sabine and James will discuss. So this particular measure of adjusted headcount ratio that you will be using throughout the summer school has very similar form to this one. Okay. Now you may argue, why don't we use I as a measure of poverty? This particular measure, you just look at the income of those poor, find out their income shortfalls, right? And use it as a poverty measure. Would that be anything wrong with it? Suppose we decide to use this as a poverty measure, which is I is equal to 1 over Q. So we identify those poor, look at their income, and just take the average normalized shortfall of these people. Suppose you have 3 incomes. Suppose you have poor person's income as 1, 2, and 9. You take the average, 9 plus 3, 2 plus 1, 12 divided by 3. Right? This is the average income among the poor. If the least poor person escapes poverty, then you are left with the people with 1 and 2. Okay? Their average income is smaller. So if you look at the normalized gap, average normalized gap, you will actually go up. So somebody has escaped poverty and you have an increase in poverty. So besides ignoring that population, that main part, what this particular measure have the problem is that you may have actually an improvement in a poor. Look, it is dividing by the number of poor, right? Which can change. So if you have a good policy, you keep some people out of poverty. As a result, the overall poverty is increasing, which is not good. That's why it is adjusted by using rather this particular measure, which is dividing by the entire population instead of just dividing by Q. So now looks like poverty gap improves a problem. So you have this example. If you have x, then x star you get. So g star is nothing but taking the normalized gap of these particular measures. So the poverty gap is nothing but you sum them up, 6, 2, 8, 9.9 divided by 4 is 0.225. Alternatively, there's an alternative computation of the poverty gap ratio. You take mu star, which is the average of all elements in X star. Okay? Then mu star over here would be 7.75. This poverty gap is 10 minus 7.75 divided by 10 is equal to the equivalent results. And poverty gap ranges between 0 and 1. When would be poverty gap equal to 1? Right, so combining these two, everybody has to be poor and everybody has to have zero income. Okay, so as a result, the normalized gap is going to be 1 for everybody, the average also 1. Poverty gap ratio, what axioms does this measure satisfy? It satisfies symmetry, replication invariance, scale invariance, focus, normalization, monotonicity, continuity. So these two were not satisfied by headcount ratio, they are actually satisfied by poverty gap ratio. Problem, it doesn't satisfy transfer. It's not sensitive to inequality. If you want inequality to be one element in that poverty measure, inequality among the distribution of poor, some might say I'm not interested. If you're interested, then this measure is not going to give you the desired result. Policy implication, it does not discourage a policymaker to distinguish between the marginally poor and the severely poor while you are making the assistance, but it also does not provide an overriding incentive to the policymaker to help the poorest. Because wherever you spend your dollar, you will have same change in poverty. So you don't have any incentive to help the poorest, rather than you can help the marginally poor and you still have, unless you are a very benevolent government, which is a completely exogenous thing coming from outside, you won't have any change, or you won't have any extra additional incentive. The next one, which is also quite frequently used, is the squared poverty gap. What is the idea? It reports the average of the squared normalized income shortfalls from the poverty line using the censored distribution X star, is also known as the FGT measure, which is you compute the average normalized shortfalls like this as we did earlier, and then the squared gap measure is nothing but the average of these squared shortfalls. What is the intuition behind it? What it is doing is that you have the normalized poverty gaps, right? What you are doing, you are weighting the normalized poverty gap by itself. So larger the poverty gap, you are assigning a larger weight. Why just square? Why not cube? Why not 1/4? You could do that, you can explore, that's fine. But this is just sort of the next to poverty gap measure that is used. And it's enough to it is sensitive enough to inequality among the distribution of the poor. Same example, suppose you have this G star, which is 0.1, 0.6, 0 and 0.2. You square the poverty gap and you obtain this, and this is just the average. Okay? And it also ranges between 0 and 1. What axiom does it satisfy? It satisfies the axiom satisfied by the headcount ratio and poverty gap. On top, it can satisfy transfer. And it can be shown this particular poverty gap, square poverty gap measure can be broken down into these three elements with this particular functional form, where H is the headcount ratio, I is the income gap among the poor, and CP is the coefficient of variation. Okay? So this is square. This is actually generalized entropy 2. So what you can do, once you compute the squared gap, it is possible that you break it down into headcount ratio, income gap and inequality, so that if you have a change in squared gap, you can try to see which element has changed. is the change or improvement due to the change in the number of poor, due to their average income, or improving the distribution or inequality among the poor. So the overall poverty measure can be broken down into the three categories to see where the change has actually come from. So when alpha is a particular parameter, the FDP class can be written as this way. So when you have alpha equal to 0, it becomes the headcount ratio. When alpha equal to 1, it becomes the gap. When alpha equal to 2, it becomes the square gap. Okay, that's it.
That's all about the summary of what we see.
Summary of
What's it for the three?
for the
For the three measures.
in general, they use 3. There, you could use this transfer sensitivity property, which requires you know, if you have transfer between to poorer person than to not less poorer person, then poverty should also change. Then you require where alpha greater than equal to 3 or at least greater than 2 or something like that. I'm not going that far. Okay, I'm just going to stop here. Okay, so as of now, I've talked about the properties that you need to know in order to understand the behavior of a poverty measure. I talked about the 3 main poverty measures that we'll be using throughout the summer school. Now, let's talk about a bit about the arbitrariness of poverty measurement. You have different poverty measurement. You have chosen a particular line. I can argue that is the wrong line. I want another line. You could say, well, you have used a measure. I want another measure. Fine. How arbitrary is the decision that we are making? So there could be 2 types of problem. One can come through identification, which is poverty line. The second is aggregation to poverty measure. Let's see. Does the choice of poverty line alter the ranking of distributions? Yes, it does. Example, suppose we have 2 distributions, this X and Y. Which distribution has more poverty by H if Z is equal to 7? That means which distribution has higher headcount ratio? Headcount ratio? Yeah. Exactly, right. Now, when you change Z to 10, which distribution has more headcount ratio? So, your conclusion changed as you change your poverty line. Poverty measure. Consider the same 2 distributions as we considered earlier. Which distribution has more poverty by H when Z equal to 10? You already said that. Which distribution has more poverty by poverty gap when Z equal to 10? Do you get the same answer? Let me do the computation by myself. So you have, again, it flipped. You changed a poverty measure, your poverty conclusion changed. So you also need to know under what conditions you will be able to say, you know what, no matter what poverty line you choose, no matter what poverty gap or poverty measure you chooses, poverty have gone down. If we can say, or if we can make these kind of statements, it has huge political strength, right? You are not choosing particular poverty line, you are not choosing particular poverty measure, yet you are saying poverty has gone down. This is something called the dominance approach. And Bubab is sitting here who is quite an expert in these kind of approaches. Okay. So the idea is to verify if one distribution dominates another distribution. Do we need to calculate all measures for all poverty lines? Well, that's a tedious task. Right? You could have infinitely many poverty lines and infinitely many poverty measures. At least 3 we have seen. The idea is that if we can have a particular tool that we can use to say such things, then life becomes easier. And such tool exists called stochastic dominance. This is closely linked to poverty ordering when we rank different distributions. But note, we can use dominance analysis. We can say no matter what happened to you, poverty has gone down. But the question remains, how much has gone down? Where has gone down? Okay, and that's what does not rule out the use of indices. That is where, and you will see oftentimes dominance approach doesn't conclude. We have crossings and all these things. You have to use indices. So the use of indices, it doesn't rule out the use of indices. Okay? It just give you some added strength. If you can say something, fine. So there are 2 main types of poverty ordering. One is variable line poverty ordering, focus on the identification step, and variable measure poverty ordering. It addresses the aggregation. The idea is that choose a measure, identify the condition that 2 distributions must satisfy so as to be able to say one has more poverty than the other. This is the results that we get from Foster and Sherlock's work, 1988. Recall the idea of distribution. Okay, for a society with large population size, this is how a typical CDF looks like. We have already been through this, right? And I told you that I'm coming back here. What does it tell us? It tells us the share of population having income less than a particular income level. So fx4 is the share of population having income less than $4. So these are the people, and this is the share of these people here. If the poverty line is 4, which is here, then what is h? H is equal to this fx4 in this diagram. Similarly, if you change it to 8, then your poverty measure is going to change here, like this. Now, if the CDF of another distribution y, which we will be denoting by fy, lies nowhere to the right of the CDF of x, then y has no lower headcount ratio than x. A bit difficult to read, not to be technically correct, but the idea is that if you have such situation, okay, and you choose any poverty line, let's take any poverty line 4, which distribution has higher poverty, higher headcount ratio? Y, right? Because this is the headcount ratio of y, this is the headcount ratio of x. If the poverty line is 8, which distribution of higher headcount ratio? Again, so you cannot find a poverty line where you are going to show x has higher poverty, right? So the first thing you may do, you have these two distributions. Suppose either you are comparing male versus female, or changes over time of one society versus another society. The first thing you could do, if you plot, suppose your consumption expenditure or your income, and you have such situation, I'm talking about population here, by the way. Okay, you have such situation, you conclude one distribution has more poverty than the other. When you are using samples, you have to consider the errors, standard error. That means if you are reporting the single one, you have to report confidence intervals. Otherwise, you have to compute the difference of these two distributions and then do a statistical test in order to be able to say that's statistically significantly different. But in terms of population, if you see this kind of two populations, their incomes and consumption expenditure, you know that y has higher poverty than x. Or suppose y is your distribution in 2000 and x is your distribution in 2010. You can conclude, no matter what poverty line I choose, no matter what poverty measure I choose, okay, mainly poverty line or poverty measure, it works as well, will show. Then poverty actually here in 2010 has gone down. You don't have to use a particular measure or a particular poverty line. Okay? Great. So you, for this particular example, if you have two distributions, x and y, then which distribution has sort of, lower poverty in that sense, no matter what poverty line you choose? Right? Because there is no poverty line for which you can show that x has higher poverty. So once you plot the distribution, even before computing your poverty measures, you plot these distributions and you know that I'm going to get lower. How much lower? Well, then you have to come to poverty measures, because it cannot tell you. It can just tell that poverty has gone down, that's it. Okay, so this is the definition of first order stochastic dominance. Please don't get scared with this particular notational things. We are not going to bring them again and again, but those of you who are interested could be useful. So for distribution x, y, x fs dy, if and only if fxb less than equal to fyb for all b, and is strictly less for some b, okay, where b is the income, you denote in this particular axis. How strong is this result? If you observe this kind of results, what you can say, if FSD holds, then there is agreement for all continuous poverty measures satisfying, actually headcount ratio also satisfies this, so it's not this design. All poverty measures satisfying symmetry, focus, scale and replication, invariance and monotonicity for all z. So if any poverty measure that satisfies this property will all agree that x has lower poverty than y for whatever poverty line you choose. This is very strong. So if in your country you get these particular two distributions, you are happy. You know, I don't have to choose a particular poverty line or particular measure. I will see a reduction in poverty. Okay? What happens when CDFs cross? In this case, FSD definitely doesn't hold because your CDF has crossed in the middle. But still the distribution can be ranked situation based on other measures for all Z. That's a different story. Second order dominance. So you move where you go from first order, you move to a second order dominance. I'm not going that far. Okay? But this is the intuition. What you do for every possible poverty line, you compute the area below the CDF. Okay? So you take a CDF and for each poverty line, you compute the area to the left of poverty line but underneath the CDF, the small triangle. So what you do, you have fx here. Suppose you have this distribution. You take suppose this z prime, again compute the entire area. If you look at this particular area, okay, this is nothing but it's related to poverty gap. Because what you are looking, you are taking the distance between these two and then multiplying by the frequency. So actually it is shown, and it's very nice paper by James Foster, where it shows that this second order dominance, so if you plot it, you will have suppose G or something, which is the area of this, and you get something like this. So even though they cross, it is possible that the second order don't. So you cannot conclude about headcount ratio, but you can conclude poverty gap and beyond, poverty gap squared, poverty gap, and so on. So this is called second order test. Poverty gap actually has a nice interpretation that Martin Ravellian actually gave. He called these curves as poverty deficit curve. Poverty deficit curve. What is the idea of this? When you look at the poverty gap measure, you look at the normalized gap, right? Now instead of normalized gap, if you just note down the gap, suppose here in this particular example, here is you have a gap of 9, here you have a gap of 8, here you have a gap of 1. You add them up. What do they tell you?
That's the amount required to take everybody out of poverty.
That is the amount,
This term.
right, to get everybody at the poverty line. So you can remove the deficit with this amount. That's why this curve is also called linked to poverty gap. It's called poverty deficit curve. Similarly, if they cross, you can go to third order stochastic dominance and so on. Let's not go that far. Okay, but it is technically possible to go that way. It's called third order stochastic dominance. So you can, so if they cross, you can still rank distributions for a limited number of poverty measures. Finally, this is called limited range poverty line. The results I presented, it ranked the entire distribution. You may say, well, I do not consider, I'm never going to consider Bill Gates as poor person. Okay, so you may say, my poverty line, is the poverty line probably ranges between a particular bound. So in that way, in that sense, you can check your poverty measures or poverty ordering for this restricted poverty line. You call them restricted dominance or something, right? I forgot the exact term. Right. So you define, so now the poverty ordering would be defined as probability of yz greater than xz for z in this capital Z. So this capital Z is the restricted set of poverty lines. So you are saying, instead of comparing the entire distribution, I would say that the poverty lines lies between 0 and $2.5 a day. That's it. And you do all this analysis, dominance analysis and so on, for this restricted set of poverty lines. Okay? So that's called restricted dominance. So when you use stochastic dominance approach, even though they cross, suppose you have crossings even in second order, in third order and so on, but at least then you know where the crossing is taking place. If the crossing is taking place beyond your interest, Okay, the crossing is taking place the right side of the distribution, you will say, you know what, I'm not interested such a high probability line. Up to this much is good enough for me. Then you can do restricted dominant kind of